What are the limits of weather forecasting? Have you ever wondered why weather forecasts sometimes miss the mark? Understanding the limits of weather forecasting can help us appreciate the science behind predicting local weather. Weather forecasting involves predicting atmospheric conditions for specific areas over time. While technology has improved accuracy, there are natural and practical limits to how well we can predict the weather. One key factor is the chaotic nature of the atmosphere. This means that small differences in initial conditions can lead to vastly different weather outcomes. Because of this chaos, reliable forecasts can generally be made up to about 7 to 10 days in advance, especially in mid-latitude regions where weather patterns are more predictable. Beyond 14 days, forecasts become uncertain and unreliable. Several factors contribute to these limits. First, data quality and coverage play a significant role. Accurate forecasts depend on detailed observations of temperature, humidity, wind, and pressure. Gaps in data, especially over oceans or less monitored regions, can reduce forecast reliability. For instance, areas with fewer weather stations often experience lower forecast accuracy. Next, we have model limitations. Weather prediction relies on computer models that simulate atmospheric physics. While these models have improved, they still simplify some processes and have resolution limits. Some weather events, like thunderstorms or rapidly intensifying storms, are harder to predict far in advance. Atmospheric complexity also affects predictability. Large-scale systems, such as cyclones, can be forecasted several days ahead. However, smaller, localized events like thunderstorms or sudden temperature changes are more challenging to predict accurately beyond a short time frame. Natural variability in the atmosphere means that even with perfect data and models, there is a ceiling to how far ahead we can reliably forecast the weather. Despite these limits, weather forecasts have improved significantly over the years. A 7-day forecast today is as accurate as a 4-day forecast was 30 years ago. Advances in satellite technology, high-resolution data collection, and computational methods like artificial intelligence are helping to refine forecasts within these natural boundaries. Understanding these limits is essential for communities and governments as they plan for weather-related hazards such as storms, floods, heat waves, and droughts. While long-term forecasts beyond 2 weeks remain uncertain, short and medium-range forecasts provide critical information for agriculture, disaster preparedness, transportation, and daily life. In summary, weather forecasting is limited by the chaotic nature of the atmosphere, data availability, and model precision. Reliable forecasts generally extend up to about 10 days, with a natural upper limit near 14 days. Continuous improvements in technology and data collection aim to push this boundary slightly further, but some uncertainty will always remain due to the complexity of weather systems.